Hey folks, I want to look at the topic of solving rational inequalities. Not a lot of you may realize this, or maybe many of you do. I don't know. Solving inequalities is not the same as solving equations. You have some of the same tricks, but some of the tricks are completely different. So I want to look at this example right here. And we're going to try to solve this inequality. X minus 4 all over x times the quantity x minus 2 squared. And let's set it greater than or equal to 0. So we're trying to solve this inequality. We could just guess and test and try to come up with an idea, but here's a methodical way of doing this. So the first thing I want to point out is notice that this is already a single fraction, and that it is set to 0. It's not really set equal to, but it's set to 0. Some of the sometimes the more difficult steps or more time-consuming steps have already been done on this problem. So the first thing you want to do is you want to go ahead to do so, make a number line. And on that number line, you're going to put any values where this expression, let me put my point to it, this fraction right here, any values where this fraction is either 0 or undefined. So I'm going to go ahead and put the number 4 up here on this number line. How come? Because this is where the expression, let me just say the fraction, is 0. And then I'm also going to put up the values 0 and 2. And these are showing up, but they're showing up for different reasons. Why are these two values showing up? This is where the fraction is undefined. So this fractional expression is undefined if x takes on the values of 0 or 2. And I think it's important to distinguish distinguish between the two reasons why we might put values on this number line. And that'll show up in our answers. So let me just give a quick word for what we've done. We've taken the number line, and in this case we've divided it up into 4 subintervals by these values here. And we know that the inequality, the fraction on the left-hand side is going to behave the same way in terms of sign for any values within the subintervals. Meaning between 2 and 4, for instance, there's no way that this fraction can change sign, because the only way a fraction can change sign is if it crosses a 0 if you were to look at its graph, or if there was an asymptote if you were to look at its graph. But we've already taken into account any way we can get a 0 or an asymptote to this fraction. So that's why this method works. So now what am I going to do? I'm now going to take test points. I'm going to take a test point from each one of these intervals. So let's take a test point. Let's take x equals -1, and we can take x equals 1, and let's say x equals 3 and x equals 5. I've sort of taken what I would think are the most natural choices for test points in each of these subintervals. But it actually, I could have picked any value, as long as it's, I could have picked, for instance, here, I could have picked 3.5 or 3.6 or even pi if I so chose, because it doesn't matter which value I pick. It's because the fraction behaves the same in terms of sign for any value within the subinterval. So now what am I going to do? Well, I'm now going to plug each one of these into the fraction, and I'm going to evaluate the sign of the fraction. I'm going to look at the sign of the fraction. So, for instance, if I let x equal 5, let's go ahead and look at this fraction. We would have 5 minus 4 all over 5 times 5 minus 2 squared. Okay. Let's see, this cleans up to be, this would give us 1 all over 5 times 3 squared, which would give us, it looks like 1 over 45. To be honest, I don't care about the fact that when x is 5, this fraction evaluates to be 1 over 45. What I care about is the fact that when x is 5, this fraction is going to evaluate to have a positive sign. Maybe I can spell, maybe I can't. It's going to have a positive sign. So regardless of what value I picked for x, here I chose 5, but as long as it was within this interval, when I evaluate this fraction, I'm going to get a positive sign. So let's go ahead and put a plus sign there, meaning any point chosen from within this interval will give me that positive sign. So we continue. Okay, so then when x equals 3, in this case I'm not actually going to evaluate it. We're just going to look at the sign. Well, the numerator, if I plug in 3 for x, the numerator is going to have what sign? Well, we'd have 3 minus 4, it would have a negative sign. So this is going to be a negative all over. When I plug in 3 for x here, we get a negative sign, or excuse me, we get a positive sign. This would be a positive and positive squared, so we get a negative over a positive. So that means this whole thing gives a negative sign. So no matter what point I pick from within this interval, I'll get a negative sign. Similarly, when x is 1, I'm just going to talk through this in the air. When x is 1, the numerator is negative, and the denominator has what sign? Well, the denominator, because of the squared term, this factor will be positive, and when x is 1, this factor is positive. So regardless of what value I pick for x between 0 and 2, this fraction will always will evaluate to be positive. And similarly, if I plug in -1, my numerator is negative and my denominator is negative. Oops, I apologize, folks. I've made a mistake. Let's talk through that one more time. When x is 1, the numerator is negative, but the denominator is positive. So this should be a negative sign here. And when I plug in -1 into this, the numerator is negative, the denominator is negative, and so we get a positive region there. So now what do we need to do? Well, now we need to actually answer the question. So let's scroll back to what the question was. The question is, when is this fraction greater than or equal to 0? Well, I can see that it's going to be greater than or equal to 0 for any values in these two intervals here. So I'm going to go ahead and give my answer. And I'm just going to go ahead and list the endpoints right now. So let's see, it's going to be positive from -infinity to 0, and again from 4 to infinity. Now, I deliberately didn't put the endpoints on here. Okay. Well, I didn't put the endpoints on here because we now need to be a little more careful. Well, certainly the arbitrary values of -infinity, infinity, those get parentheses. But let's talk about this. Our inequality says greater than or equal to. Are we going to include these endpoints? Well, it's actually kind of an interesting question. In this case, because the inequality is greater than or equal to 0, we know that if we plug in a 4 into this fraction, we get a 0. So we are going to include the endpoint of 4. But why did we initially list 0 on this number line? Because we said the fraction is undefined there. So it doesn't make any sense to say that at 0 the expression is greater than or equal to 0, because at 0 the expression is undefined. So we cannot include 0 in our solution set. So what I'm emphasizing here, and this is why I've taken so much time to do this video, is I'm emphasizing the difference in these two endpoints. So for those of you that feel pretty comfortable with that, you can probably end the video now. On the next page, I'm going to outline these steps a little bit more, in a little more detail, and do one more example. So here are the steps to solving a rational inequality. The first thing you do is you need to put the inequality in the form of a fraction, then whatever the inequality is, and then 0. So you write the expression as a single fraction and set it to 0. Not set it equal to, but set it to 0. So let's just look at this example, and I've already done the work for this. We've got the inequality x all over 2x minus 1 is less than 1 over x. So unlike our first example, this is not in the form of a fraction, inequality, and 0. So the first thing I need to do is let's go ahead and take this expression over the other side. I've done that here. Then I need to write this expression as a single fraction. So to do that, I need a common denominator. Well, my common denominator in this case is going to be x times 2x minus 1. So we can see that the first fraction is missing the factor of x from the common denominator, so we multiply this by x over x. The second fraction is missing the 2x minus 1 factor in the common denominator, so we multiply this by 2x minus 1 over 2x minus 1. So the rest of this is just me cleaning it up until I get down to here, and now this is in the form of a fraction set to 0. So this is, for this method to work, it does need to be in this form. So then we identify the interesting points. Where is the fraction either 0 or undefined? Well, the fraction is 0 at x equals 1, and it's undefined at x equals 0 and x equals 1/2. Okay. So then I say to put all these points on a number line, so let's go ahead and do that. So we'll make ourselves a number line, and on the number line we'll put the 3 interesting points. So let me put 0 here. We'll put 1/2 here, and then we'll put 1 here. And what do? Well, the next thing we do is we pick test points. Okay, I can do that. So we need some test points here. Let's take -1, let's take 1/4, let's take 3/4, and let's take 2. And we're going to plug them into this inequality. So we're plugging each one of these test points into the original fraction, and all we're doing is determining the sign. So if I plug in a -1, well, notice first of all that we'll carry this through the whole evaluation process. The numerator is always going to be positive, so the only thing that matters is the sign on the denominator. When I plug in -1 in for x into both these factors, they both become negative, and their product is positive, so that means the entire fraction is positive on that interval. If I plug in 1/4, this factor is positive, but this factor is negative, so the denominator is negative, making the entire fraction negative. If I plug in 3/4, then all these factors are positive. Likewise, if I plug in 2, then all those factors are positive. So if you have any questions, pause the video and think about that. Or let me know, of course. So now we can go ahead and answer the question. Well, we were asked to determine where is this thing less than 0. Well, the answer is that it's less than 0 between 0 and 1/2. And then the question becomes, well, what about the endpoints? Well, let's remind ourselves, why did we put 0 on the number line to begin with? Well, that was because that was where the fraction was undefined. And why did we put 1/2 on the inequality? Well, that was also because that was where the expression was undefined. And so our solution set is just this interval right here. Okay. Just for fun, since I've already done all this work, let's suppose we were asking this question. When is x minus 1 quantity squared all over 2x times x minus 1/2? When is this, let's say, when is it greater than or equal to 0? Well, this has a solution. If all the work's the same, we just look at our graph up here. This has a solution that will go from -infinity to 0, but we don't include 0, unioned with 1/2, but we don't include 1/2. And here I'll go ahead and do this in 2 parts. Up to 1, but we get to include 1. Why? Because 1 is up here, because this is where the fraction is 0. And then again from 1 to infinity. Of course, we can go ahead and combine these two inequalities into a single inequality, so I'll do that now. This goes from -infinity to 0, unioned with 1/2 to infinity for our final solution set. Anyway, this video was a little longer than I'd hoped, but I hope this was helpful. Please, if you're having any trouble, please come see me. Especially if you have any trouble with this part right here. This is, these steps right here, this algebra can sometimes be a little tedious. So anyway, I hope this was helpful, and if not, please let me know. Thank you.